Hello again, everybody. I hope yesterday's assignment went okay on these compound inequalities. If you haven't seen that video yet, you really need to watch it before this one because this builds on that and it takes it further. We're getting into special cases now, and you have to have a good foundation on the previous assignment in order to go with this. So there are four special cases we're going to be looking at. One is when you have overlapping arrows in AND problems, and again, those are called conjunctions. The second is overlapping arrows in OR problems. The third is when you have no solution in AND problems, and the fourth is when you have all real numbers in OR problems. So these are four separate things that can happen. Let's get right to the examples. I'll point them out as I go, and then I'm going to have to point out a little mistake that I made, but it's not a mistake. It's slightly more confusing than I would have wished it to be. So we'll talk about that when we get there. But here's number 2. So this is a conjunction. It's an AND problem. I'm going to rewrite it down here so that I have room to work. Notice this one is not in that special notation, and you cannot make it in the special notation. We just have to work it out the way it is for now. Maybe when it's done, we can put it in the special notation. We'll see. So the first one, we want to isolate this v, so I'm going to start by subtracting 8 on both sides. 10v greater than or equal to 80. Divide by 10. V is greater than or equal to 8. So good, we got that. Bring down the word and. The second one, going to be pretty simple to isolate v. You just subtract 4. You get v is greater than or equal to negative 3. I'm going to write it down here, greater than or equal to negative 3. And so that's what we have. Now, v is greater than or equal to 8, and v is greater than or equal to negative 3. Can you think of a number that's both greater than 8 and greater than negative 3? I'm going to throw out 3 different numbers. Let's say we got negative 10, we've got 5, and we've got 20. Is negative 10 greater than 8? No. Is negative 10 greater than negative 3? No. So negative 10, oops, I'm going to erase that highlighting. Negative 10 is not a solution. Let's look at the number 5. Is 5 greater than 8? No. Is 5 greater than negative 3? Yes, yeah, it is. But and means that both have to be true at the same time. So is 5 greater than negative 3 and greater than 8? No. So 5 is not a solution either. Let's look at 20. Is 20 greater than 8? Yes. Is 20 greater than negative 3? Yes. So 20 is a solution. Does that mean 20 is the only solution? No. How about 21, 22? What about 15? What about 10, 9, 8.1? Do you see where I'm going with this? All right, let's keep all that in the back of your mind. Oops, I didn't mean to erase the v. Let's look at graphing this. V is greater than or equal to 8 would be a dot and shading greater than, which is this way. V is greater than or equal to negative 3. I'd have to go way back here to negative 3, wherever that is, put a dot and shade this way as well. So what we have here is 2 overlapping arrows. One arrow is overlapped by the other arrow. And can you see there that the highlight is a little darker where it overlaps? If we go back up here, overlapping arrows and AND problems, this is the first special case. So what do you do? Well, let's go back to what the answers were. We figured out that 20 was an answer, but 5 was not. This is not an answer. 20 is. Besides 20, so was 19, 18, 17, 16, all the way down to 8. So when you have overlapping arrows in an AND problem, you only include the smaller arrow as your final answer. M is greater than or equal to 8. M, where did I get M from? That's the letter V. Genius. Okay, V is greater than or equal to 8. The V is greater than or equal to negative 3. All of these numbers over here do not fit the and part of the statement. So they are no good. It's sort of like extraneous solutions that we had before. We do not count that as part of the answer. Only v is greater than or equal to 8. So let me go down to number 2 and make sure I did it right. Yep, right there. So overlapping arrows in and problems, you only use the smaller arrow, or the one that's overlapped, the one where the shading happened twice. Remember how this one was, this one was a little bit darker than the other? That's the arrow, that's the answer. Number 4 is another and problem. This is written in the special notation. Here's why I said I made a bit of a mistake. I should have made 3 a little more like 4, so you had some consistency there. Instead, your 1 and 3 are both going to be like problem number 2, sort of. Well, in the way it's written. It might not be the same special case. So here, we got to work this out and see. Tell you what I'm going to do. I'm going to rewrite this like this, with the word and then negative 4n plus 8 less than or equal to 4. So you can split it up into one inequality like this and another one like that. The only reason I'm doing it this way is so it matches this problem that actually has the word and. I could just work it out as it is. I'm not going to. All right, let's solve this. So we want to isolate n. I'm going to subtract 8. I get 40 less than or equal to negative 4n. That's negative 4 times n, so I have to divide by negative 4. 40 divided by negative 4 is negative 10. We divide by a negative, divide by negative. So that means we have to flip the sign around. Yesterday I wrote special rule, whatever. So we get negative 10 is greater than n, or if you want, you can invert it so that n is less than or equal to negative 10. Now work the other one out. Subtract 8 on both sides. Negative 4n is less than or equal to, what is that, negative 4. Divide by negative 4. Again, we're dividing by a negative, so you have to flip the symbol. Negative 4 divided by negative 4 is 1. And we get the word and here. So n is less than or equal to negative 10, and n is greater than 1. Now, is this going to be overlapping arrows? Let me graph them both and see. So negative 10, is way down here. It would be a dot, and we would shade in the less than direction. N is greater than 1 is right, greater than or equal to 1 is a dot right here. Greater than, we'd shade in this direction. Now remember yesterday, 2 arrows pointing away from each other? Those are always or statements, or disjunctions, not and statements. So what's going on here? Let's go back to the logic of it. N is less than negative 10 and n is greater than 1. Can you think of a number that is less than negative 10 and greater than 1 at the same time? That's impossible. The same number cannot be less than negative 10 and greater than 1. That'd be like saying, can you be older than 30 and younger than 15? No, you can't. It's impossible. This is an impossibility. We still had to do a bunch of work to get there, but what we have here is impossible. Or it's basically a false statement. You cannot have a number less than negative 10 and greater than 1. So this is a no solution problem. When there's no solution, there is no graph. You don't shade any numbers if no numbers are solutions. So the answer to number 4 is no solution, and the graph should be blank. And there it is, no solution, blank graph. And okay, just cut to the chase. You see that number 3 is the same. I still want you to try number 3. I want you to show your work. I want you to bring this down, work it all out, and then at some point you should come up with some sort of an impossible statement like, what is here? We're using the letter n again. Something like, n is less than 5 and n is greater than 5. That's impossible. N is less than 2, n is greater than 30. It just can't be done. Okay, so those are 2, I guess not in the right order, but 2 of our special cases. An and problem with overlapping arrows, you just do the smaller arrow, and an and problem where it's basically impossible, and that's no solution. And there's no arrow to draw at all. Let's look at number 6. So this is going to be either like number 2, or the overlapping arrow, or it's going to be like number 4, because everything we're doing today is special cases. Let me copy this down. And go through the work. So the first one's easy to solve. You just subtract 1. X is less than 0. The second one is going to be a few more steps. So take away 2. 10x is less than or equal to negative 90. Right? Negative 88 minus 2 is negative 90. Divide by 10. X is less than or equal to negative 9. So let's graph both of these. X is less than 0. 0 is over here. And we would shade in the less than direction. It'd be a circle on 0. And negative 9, x is less than or equal to negative 9. That's going to be a dot here. And less than is shade this way. So this is a case where we have the overlapping arrows. Which one is the shorter or the smaller arrow? As far as what you see on your paper, it would be this one right here. So erase the other one, which means that part of the solution was extra, is just this. X is less than or equal to 9. So the only numbers that are less than or equal to 9 and less than 0 are these numbers. Let me check it though, because I've made mistakes before. Always self-conscious when I record. Here we go. Those are the two answers. All right, so what we had was a little repetition of the overlapping arrow scenario. Say that 5 times fast. All right, number 8. Now we're into an OR problem. So what were the special cases with OR problems? There was also a situation where you have an overlapping arrow. What is that going to mean? And how could we possibly get all real numbers out of an OR problem? So let's see what this one is. Going to bring these down and work them both out. 9b minus 1 greater than negative 82, or 8b minus 7 greater than or equal to negative 39. Let's go through the steps. Plus 1, 9b greater than negative 81, divide by 9, b is greater than negative 9. Let's work out the other one. Plus 7, 8b greater than or equal to negative 32. Divide by 8, b greater than or equal to negative 4. And then we put the word OR here. Now let's think about the logic of this before we go to a graph. Can you think of a number that's greater than negative 9 or greater than negative 4? I'll throw out some numbers here. Let's look at negative 10, negative 6, and how about positive 2? Is negative 10 greater than negative 9? Now I know 10 is greater than 9, but negative 10 is actually less than negative 9, so no. Is negative 10 greater than negative 4? Again, no. 10 is greater than 4, but negative 10 is not greater than negative 4. What about negative 6? Is negative 6 greater than negative 9? Yeah, it actually is. If you look at the number line, negative 6 is here, negative 9 is there. This is on the greater than side. So that's a yeah. Is negative 6 greater than, greater than negative 4? Here's negative 6, here's negative 4. No, it's not. It actually is not. But with an OR statement, as long as one of the two statements is true, it is a solution. So negative 6 is a solution. What about 2? Yeah, 2 is greater than negative 9, and 2 is greater than negative 4. But it's not an AND problem, it's an OR problem, so only one of those had to be true. They're both true, which is great. 2 is a solution, but so is negative 6. So what other numbers? What arrows here? So let me go ahead and draw both of these and see if we can pull this together. b is greater than negative 9 is right here. Circle, shade this way. b is greater than or equal to negative 4 is right here. It's a dot. shade this way. Once again, you can see we have two overlapping arrows. Remember, with an AND statement, you only counted the smaller arrow. What do you think you do with an OR statement? Well, as we saw, negative 10 didn't work. That's why there's no arrow here at all. Negative 6 did work, so did positive 2. Those were both solutions. Negative 6 is covered by the bigger arrow, but not the smaller one. Negative 2 is covered by both arrows. So when this happens, your solution is the bigger arrow. So you don't even need to graph the other one. The bigger arrow is all you need. So it's the larger arrow. The larger arrow came from this part of the inequality. So the rest of the solution is extraneous. We don't need to include that. So the only answer is b is greater than negative 9 because, once again, a number that's greater than or equal to negative 4 is already greater than negative 9, so it's redundant to say it twice. So that should be our answer. Let's check number, what was that, number 8? And there it is. Check, check. Let's look at number 10. So we have 2 plus 3b less than or equal to negative 22, or 10b plus 5 less than negative 5. And we need to solve both of these. Minus 2, 3b is less than or equal to negative 24. Divide by negative 3. b is less than or equal to, what is that, negative 8. Solve the next one. Subtract 5. 10b is less than negative 10. Divide by 10. b is less than negative 1, right? Negative 10 divided by 10 is negative 1. Put the word or in between there. Now, let's graph this and see if we have overlapping arrows. b is less than or equal to negative 8. That's way over here. And that would be an arrow going this way. Oops. Get out of here. Oh, gosh darn it. What? Sorry, did not mean for any of that to happen. All right, second arrow, b is less than negative 1. So that's a circle on negative 1, shading in the less than direction. That's this way. So yes, we do have overlapping arrows. Which one is the larger arrow? That would be this one, which means that is extraneous. We don't need to include that part of our answer. So our graph, oops, trying to erase here. Our graph would just be this, the larger arrow. I'll put larger in quotation marks. And let's see if that's right for number 10. There it is, there it is. So yesterday we saw with OR statements, a normal graph was two arrows that point away from each other. When they overlap, you choose the bigger arrow. Unlike AND problems, if they overlap, you choose the smaller arrow. All right, number 12, and we are done. How much you want to bet that this is going to be in all real numbers? Because we've already covered this. Oops. We've already covered this. We've covered the other ones. This is what's left. Logic. Pays to have logic. So why is this going to be in all real numbers? Let me rewrite the problem down here. Or 4x minus 8 less than or equal to 8. What is going on with that 4? Man. Okay. Work these out. Minus 1, minus 1. Negative 9x less than or equal to 90. Divide by negative 9. X greater than or equal negative 10. We divided by a negative, divide by a negative, so we had to flip the sign. Let's work the other one out. Plus 8, plus 8. 4x is less than or equal to 16. Divide by 4. X is less than or equal to 4, and we're supposed to put the word or in between those. Let's look at the graphs. Just go ahead and look at the graphs. X is greater than or equal to negative 10. That's going to be a dot on negative 10 way back here somewhere and shading this way. x is less than or equal to positive 4, that's a dot here, and shading this way. What appears to be shaded on this number line? It looks like every number is shaded, and some of them are even shaded twice. Well, let's just think about this. What numbers are greater than negative 10 or less than 4? Reason that through. Can you list some numbers that are greater than negative 10? Negative 9, negative 8, negative 7, dot, 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 5, 30, 1 billion, whatever, right? From negative 10, even negative 10 is equal to negative 10. Now, what numbers are less than or equal to 4? That'd be like 4, 3, 2, 1, 0, all the way in forever. Throw in the decimals and the fractions, and it looks like this is every single number. Every single possible number that you can think of is either going to be greater than negative 10 or less than 4. That'd be like me saying, only people younger than 16 or older than 5 are allowed to come into my classroom. Well, that would be everybody, because everybody is younger than 16 or older than 5. I mean, it's just the way it is. That's everybody. So this is, I'm beating around the bush here, this is all real numbers. Or remember, let me make that look like the word real. All real numbers, or we have this symbol, a capital R with 2 sticks on it. That means all real numbers as well. And what is your graph supposed to look like? Well, basically what I had on there was good enough, but essentially the whole thing, the whole number line is shaded. So you end up with a statement. Your final answer is true for all numbers. Therefore, it's an all real numbers problem. Let's check number 12. Oops. And there it is. So number 11 should be pretty much the same way. Number 11 is a lot like number 12. In fact, I made this worksheet to kind of pair up like that. So everyone that you do, if you look to your right, it should be a very similar problem. Okay, I'm going to go ahead and stop there. As always, if you have questions, contact me. I can answer you through email, or I can set up a Google Meet and explain things, or come to our regular live session and I can work through these problems if you need me to. Until I see you again.